Okay, this is just some basic questions in the book on Core 2 geometric sequences. So for example, example number 2, we have 3, 6, 12, 24. That's geometric because this divided by this is the same as this divided by this, which is the same as this divided by this, in other words 2. So therefore we can set up a formula for that. The term formula is this. So the nth term is A is the first term, the ratio R is this divided by this. So that's now good to go. So the 10th term is 3 times 2 to the power of 10 minus 1, which is 3 times 2 to the power of 9. Work that out, and that's your 10th term. And the nth term, we've actually already given us that one there. Now for this one, that divided by that is the same as, so wait on, that's 40. That divided by that is the same as that divided by that, which is the same as that divided by that. This is certainly geometric, so the ratio is that divided by that, which is negative half. So our term formula is 40 times negative half to the power of n minus 1. And so the 10th term is 40 times negative half to the power of 9. So that was example number 2. Example number 3. Kicks in the advice always to write out the first couple of terms, even if you need to use blanks. So we have blank 4 blank 8. Just gets you in the groove. Now using the term formula, the second term is the mystery A times the mystery common ratio times 2 minus 1. But we know as a fact that that is 4. The fourth term is the mystery first term times the mystery common ratio to the power of 4 minus 1. But we know for a fact that that is 8. So simplifying these, we have AR equals 4 and AR cubed equals 8. So do 3 divisions. That divided by that is 1. That divided by that is R squared. That divided by that is 2. So R equals the square root of 2. And therefore the first term, find the simplest line that mentions A and R, which is that. So A root 2 equals 4. Therefore A equals 4 over root 2. And the 10th term is T10 equals A R 10 minus 1 equals 4 over root 2 times root 2 to the power of 9. Simplify that, and that apparently comes out to be 64, and so that's the answer to that one. So that's example number 3. Example number 4. 3 numbers, 3x and x plus 6. That's me just writing out the terms to get myself in the groove. We're told that they're all positive and that they're a geometric sequence. So in other words, x over 3 equals x plus 6 over x. So, multiply both sides by x. Now multiply both sides by 3. It's a quadratic. Pump that through the quadratic. Oh, wait on, you can factorize that, I think. I was going to say you can pump it through the quadratic form, you certainly can. Told that x is positive, so that can't be right, so therefore the x is 6 and the sequence is 3, 6, 12, which is certainly doubling. So that's the continuation of the sequence there. And our formula therefore is Tn equals 3 times 2 to the power of n minus 1, so the 10th term is 3 times 2 to the power of 9. Simplify that and you get your 10th term. In 7C they give you some backwards questions, and I do a lot of them for real world problems in the mixed exercise, but I'll just take you through the backwards question in example 6 for 7C. It's 3, 6, 12, 24. What's the first term to exceed 1,000,000? So the nth term is Tn equals 3 times 2 times n minus 1. That's the first term, that's the common ratio. So what I'm going to do is investigate when it's equal to 1,000,000. It probably won't be equal to 1,000,000, so I'll probably get a n being a non-whole number. But because this term is clearly increasing, if I get n, for example, equals 55.7, that means that the 56th will be the first term to exceed 1,000,000, and I can therefore work that out. So anyway, 2 to the power of n minus 1 equals 1,000,000 over 3. So therefore, the power you have to put on a 2 to get a 1,000,000 over 3 is n minus 1. So therefore n equals that plus 1, which is 19.35. So therefore the 20th is the first to exceed 1,000,000. So therefore that term is that. Now, just querying the wording of the question. What is the first term to exceed 1,000,000? So I probably should say what the term actually is, though in the book it just tells you which position it is. It thinks it's enough just to state the position.